Okay. So, okay, it's rather small, but anyway. So I will talk to you. Thank you for your, sorry? Oh yeah. So thank you for your attendance and staying so late today. Of course, you will be there tomorrow, so there's no problem. I will talk to you about Gemvid, which is a software we developed at the University of Liège. And I'm a biologist. I'm Jean-Etienne, and Laurent is engineer. And we developed this because we need to know how our animal behave in their cage, and we can't stay there during the whole day and night. So obviously we were not the first one to think about something to measure the activity of animals, and the first device that comes in mind is the running wheel. So you have a wheel over there and your mice or of your rat is just there running. The problem is that what are you doing when your mouse or rat is outside the running wheel? You can't put the rat over there for 24 hours a day. And the second problem is that you measure only the motor activity and not the general activity. If the rat is just moving the head, you can't see it. You can see it, but you can't measure it. A thing quite nice that were published when we thought about our solution in an open access publication was using a radar and with a complicated device, but everything was free. So that's a good point. But do you really want such a complicated hardware? A third method is just video tracking. So you put the rat in the cage and you follow him. That's a good idea, to follow the rat. But usually it's costly because there is no free implementation. And the second point, it's impractical because the software, what the software does is it takes the animal, it takes the center of gravity only, and then it puts some red points all over the animal so that, well, your animal is there, you know, but what it measures is only the center of gravity. So again, it's motor activity and not general activity. So a final solution is markers, like people do in virtual reality systems, but really rats don't like these things. They just chew them and it's over. So what we want is the quantification of, the quantification, again, okay, the keyboard is better. No, it's blocked. I can go. So the goal is to develop a general monitoring system, okay, it's there, without any marker and using commercially available CCTV and modular free software. Why commercially available CCTV? Because, you know, we are in a university and we don't have extensive research budgets. So roughly, the principle we use is the frame difference analysis. And if you take I will try it once more, okay. If you take a rat at one time and you take a picture of it, and then at the second time you take another picture of the rat, and here it's every 1/25 of seconds, you can compare the two images and you compute the number of pixels that are different here in green. So the setup is the following. You have your rat, you have a camera, you have a computer that analyzes the images, and then you have two displays, one with the animals, and if, well, at the first row you can see it more clearly. Then if I move my fingers, you have some green pixels showing. And after that, you can analyze the output with a general graph like you want. So here are two pictures of our system implemented in a real laboratory. So the main thing for a biologist is that the rats are well their wellness. And here it's okay because, well, they are alone in their cage, but at least they have their friends around. So for a rat, which is a social animal, it's very important. So if people want details, here they are. You can use with our system any camera. Here you need infrared if you want to use 24 hours of recording, because when it's dark or night, you need to have something on the screen. And for example, we used a camera from China, which costs 60 euro on eBay, and the travel costs are included. You can use any video for Linux enabled frame grabber. Well, we use a frame grabber because we have a camera, but here on the laptop you have a webcam, so you don't need any frame grabber. At least if the webcam is supported by Video for Linux, it will work. My webcam is not infrared, so it will not work during the night. We use an ATI Rage 120. Now it costs, let's say, 5 euros. And you can use any computer running Linux. We use a P2. That cost, we checked this afternoon, 35 euro on eBay. And on the hard, so everything is 100 euro. On the software side, you use GNU Linux. We use a rather old version of Red Hat, version 7.3. Of course, the Video for Linux API. We have no other dependencies, and we have an output in ASCII, so you can throw your data anywhere, even in a file if you want, and then you can visualize your data with GD, Scilab, Python, imaging library, I don't know, name your favorite software. So, of course, on the scientific basis, we did a theoretical validation, and we demonstrate that our system is precise, sensitive, reproducible with rodents. We compare it with an ActiWatch, which is the system for human in measuring their activity, and it's stable over time. So if you want, later on, we can go into details about that. And if you want to check everything, it's published in an open access journal on the web. So, and finally, let's see what's happening with the rats. So the rats has a different circadian rhythm than ours, and the rats are merely quiet, not, I won't say asleep during the day, during the light phase of the 24 hours, and more active and very active during the dark phase, so during our night. And so during the day, when usually people are around in the lab during their experiments, the rat is not moving. So this picture can be taken by anything, your webcam, my webcam, Gemvid, anything. But what is interesting is that during the night, the rat is moving. And here you can see all the green pixels around the rats, showing that here it didn't move anything with the legs. So the running wheel would not have kept or detected these movements, just the head with the ears over here, and the tail, and a little bit over here. So that's why it's, for me, very interesting. So after that, you take the output and you plot them in what we call actigram. So it's the amount of movement versus the time, and here each block is 1 day, so 1, 2, 3, 4, 5, etc. And the dark block above are the night or dark phase, and the day or light phase, and everything starts at midnight. So as you can see, the rat is more active during the dark phase than the light phase. And this rat was quite interesting because all the time around, I don't know, 10, 11, he just jumped out and did something, and then everything else. So it's interesting because all these were collected automatically, so no intervention, the rat is just there, food is available, water is available, and no human intervention. So after that we can say, okay, this rat was compliant with the treatment or not compliant, or did well or did not well, depending on your experiment. So in conclusion, we can say that Gemvid is sensitive, reproducible, stable over time, more accurate than an ActiWedge, and we proved it with rodents. So if you have some pets and all, you can test them, and we can come and we will publish another paper with them. So the one interesting thing is that it's non-invasive. And one last thing I just discovered quite a few minutes before the talk is that it's very light. The archive is only 52 kilobytes, so it can be set up nearly everywhere. So what is more important for us is that it uses commodity hardware, and it's free, as is in free beer, and it's free as in free speech. So I want to thank a lot of people in my lab, but I want also to thank you for your attention, and if you want, here are the URL to get the archive, the paper, but more importantly, if you type Gemvid in Google, you will find them. So thank you very much. Are there any questions? Yes?
Could certain behaviors be detected, such as sleeping, moving, and could you then apply that to human tracking systems?
As such, the system cannot detect behavior. So, I mean, in the output, you can't see at one point sleep or something like that. But we developed this system because we used a regular sleep system for a rat, EEG, electroencephalogram, and it was very difficult for us to do it in an automated way, and we don't have a lot of space on our hard disk, so it was impossible for us to store 24 hours of sleep or not sleep, but we don't know, so we store everything. So with this system, you can say below a certain threshold, okay, maybe the rat is asleep or not, but just record the sleep in case, and then after that review the sleep. And so, as you can see, the rat is not moving all the time, so he's quite moving very often. So it reduces also the amount of electroencephalogram that the scientist has to review. But your question is very interesting because it's one of the next step we want to do is that to categorize a certain pattern of what moved. If the rat only moved the head, it can mean it's only drinking, eating, or maybe just nodding. So it also means it's not sleeping, it's not moving, so we can categorize certain behavior, and that's what we are kind of working on.
Do you have a sensitivity threshold? I mean, will you pick up the rat
Yes.
breathing, for example?
Yes, and breathing, and more importantly, everything depends on the quality of your camera. So here the camera was very good because we inherited from a very successful lab. But we use some camera with a lot of noise, even if there is nothing in front of the camera. So there in the setup process, you have to define a certain threshold. Below, I don't know, 20 pixels in the image, I don't want to see anything. So after that, above 20 pixels, yes, okay, show me the data and let's see. But you have the raw data, so if you don't know what your camera, how your camera will behave, or suddenly your camera goes wrong, you can say, okay, let's see the data, you have your data, and at one point you say, no, this is not good, you have too much noise at one point, then you can reduce at one point. So you can act before the recording and after, no problem. Yep. Yeah. So that's a good point. The question was, can we use multiple cameras from different angles, for example, to see all the movements? And if you remember, all the images are taken from the largest side of the cage, because more of the movements are done in that plane, if I can say. But it could be interesting to have two cameras, and since, well, the system is not using much of the processor, it couldn't be difficult to put a second camera for the processor, and have the two logs at the same time and compare them or merge them into a summary, yes.
All right. Well,
Thank
thank you for your talk. I'd like to give you some better talk, but please don't feed it to your rats. And otherwise, thank you.
Thank you.
So I'd like to say, yeah. So I always like to end with an open source talk that's a bit different, but believe it or not, 3 talks ago, I actually saw a mice crawling out of the ceiling, running here in front and going back. And I wish I could have taken a picture. If only I've had your system, I would have it. Okay, so thank you for coming to the lightning talks. Can I just shortly ask if you would take any trash that's around you, throw it there, that will save us some work, and then we'll see you tomorrow. Thank you very much.